In this video, we look over the different versions of image classification. The first one is the easy version, which is image classification with mobile unit. We install TensorFlow, Keras, and TensorFlow Hub that are also tools needed for model loading, training, and image handling. We import the core libraries. PIL is used for image loading and Matplotlib for visualization. Then we load the pre-trained mobile net v2 from TensorFlow Hub and wrap it in a sequential model with the appropriate input shape. We download a sample image, resize it to 224 into 224, normalize it, and add a batch dimension. We run inference on the image and get the predicted class by taking the index with the highest score. Using the provided ImageNet label file, we map the class index to a human readable file. We show the image and overlay the predicted label. This confirms whether the classification results match visual expectations. MobileNet V2 provides fast, reliable predictions even on CPU. The result in this case of which is like a military uniform matches the image, showing excellent generalization. And we also have the confidence score. The intermediate version is custom image classifier with transfer learning. We load the feature vector version of MobileNet V2 and freeze its weights. This means we'll only train the classification head. We add a new dense layer with softmax activation for a custom classification task, such as for datasets like flowers or dogs. We use the Adam optimizer and categorical cross entropy for multi-class classification. We train for a few epochs. Since the feature extractor is already trained, training is fast and the model performs well even with limited data. Transfer learning reduces compute cost and training time while maintaining high performance with just a few samples. The model hits over 90% accuracy. And here we have the graph as well. The advanced version is neural style transfer. This model takes the content of one image and style of another to produce AI generated art. We load the magenta model, which allows arbitrary image stylization. We just use two images for the same. This function handles loading and resizing both content and style images to 256 by 256. The stylized image, we generate the stylized output in one line. TensorFlow Hub handles all the heavy lifting. We display the original content image, style reference, and the stylized result, beautifully combining the two. The model transfers brush stroke, color palettes, and style while preserving layout and edges. So, for example, first we gave a picture this, then this, and this is what we get as the output. Now we see the expert version, which is style transfer with arbitrary image stylization, that is batch stylization with performance benchmarking. We take this to the next level by adding timing benchmarks, batch stylization, and multiple style image inference, which is a great example for real-time or batch processing. First, we measure how long it takes to style an image, critical for applications like real-time video or mobile art apps. We reuse our content image but change the style, trying Picasso, Van Gogh. The result changes drastically depending on the reference. And we see that the performance is consistent and output remains high quality. For example, when we gave reference here, first it took style transfer to 3.67 seconds, but when we gave a Van Gogh reference, it only took 1.4 seconds, and you see drastically reduced the computation time.